Looking at that chart, when you're looking at that chart, what you want to be able to recognize right away is you really only need to know two of them. What are the two that you need to know?
30, 45.
No. What trig functions do you really need to know?
Sine, cosine, tangent.
As long as, you don't even need to know tangent. As long as you know what your sines and cosines are, doesn't everything mirror off of that?
Yes.
As long as you know what your sine and cosines are for your 30, 60, and 45, everything else is fine. So take a look and see if you got them right. What I did there is I just grabbed a chart that works. Let's continue what we're talking about. Yesterday, no. I just wanted you guys, basically the idea was I wanted you to do your table to help remember these things. And then reference angles are relatively straightforward. What I want to build off of this with today is to continue talking about where everything is positive and negative. All right. Now, we talked about this a while ago, that within our ordered pairs, it went cosine, sine. Remember that? You said the x value was the cosine, bless you. The y value was sine. And as we walked around, we were able to tell what quadrant everything was positive or negative. So cosine and sine are both positive in the first quadrant. What's negative in the second quadrant? Cosine is negative here. Sine is positive. They're both negative here. And here it is cosine and negative sine. Now, without having to relist out everything else, where is secant negative? Where will secant be negative? Which quadrants? Yes.
4 and 3.
Quadrant 2 and 3. Remember, when we're talking about all the 6 different trig functions, as long as we know sine and cosine, and we know where sine and cosine is going to be positive, I know where cosecant and secant will be negative. I know where cosecant and secant will be positive. I also know when tangent will be positive and tangent will be negative. Yeah?
Where sine is positive,
Where the sine is positive, cosecant will be positive. They're going to be the same. They're going to be negative at the same spot. They're going to be positive at the same spot. The weird one comes into play when you're talking about tangent. Remember, tangent was found by sine over cosine. Remember that? Y over x. So in order for tangent to be positive, sine and cosine are both negative, or they're both positive. So for tangent to be positive, it's in quadrant 1 and 3. For cotangent to be positive, it would be 1 and 3. For tangent and cotangent to be negative, it would be 2 and 4. You're playing around with the signs, S-I-G-N, with these, the positives and negative values, to figure out where tangent and cotangent becomes negative. Now, the book writes it out as a very generic, where everything's positive and negative. I don't like to show this for a long period of time, because I think it is more important that if you know where sine and cosine are positive and negative, everything else just falls into place, okay, without having to overburden yourselves. So what is the, no. What's that? Yeah, and we'd already talked about that. If sine and cosine are both positive, tangent's positive. Sine and cosine are both negative, tangent's positive. All right. Yes, sir.
Why is y sine cosine?
It's based off of this. It's based off of the insert, and we're getting to it. Yeah. That's why we said, as long as you know that your ordered pairs go x, y, cosine, sine, it's positive. Okay. So, what is this getting us to be able to do? Let's not get that. Let's do this. It's going to allow us to do this. Oops, didn't go on the sheet, sorry. We're going to do that without a calculator. You don't need a calculator today.
Oh, no.
I don't know.
Which means we need to work on our unit circle, which means we have to build our reference angles. Here's what we do.
Isn't that in the fourth quadrant?
As we go through our unit circle, one of the things that I want you guys to remember is quadrant 1. If you know quadrant 1, you know all of them. For example, when we draw it out, we have those 3 angles. We start at 0, 30, 45, 60, and 90. Everybody okay with that? 90 is pi over 2. 45 is half of that. What is it? Pi over 4, good. 30 degrees is how much of the circle? Pi over 6. 30 degrees is pi over 6. Oops. And this is pi over 3. So right there, I have everything written out as far as radians and degrees are concerned. Now, that's going to be your reference angles. All of those are the reference angles. Now, as you draw through this, from our chart yesterday, what was the cosine of 30? Remember, cosine of 30 is adjacent over hypotenuse. It's root 3 over 2. So the x value is root 3 over 2. The y value, the sine of 30 is 1/2. The cosine of 60, 1/2. The sine of 60, root 3 over 2. Everybody okay with that so far?
This is just assuming everything you want, right?
Yes. This is it's they're always going to be based off this. They're always going to have that same ratio. This is the ratios of sides. It's always the same. 45. Sine of 45 is 1 over root 2, otherwise known as
Root 2 over 2.
cosine of 45 is the same thing. From just that information and knowing how to draw a 30, 60, 90 and a 45, 45, 90, you can fill in first quadrant of the unit circle. After you do that, using positives and negatives where the sign, SIGN, changes in each quadrant, you know everything else. Everything else just mirrors itself off of that. You're using reference angles off of 30, 45, and 60 to bounce into each of the quadrants. Now, when I'm looking at sine of 7 pi over 4, what I want to do is create and figure out what its reference angle is going to be. 4 goes into 7 how many times? 1 3/4. So I come around 1/2 and 3/4. Which means, what is its reference angle?
Pi over 4.
Pi over 4, good. So its reference angle is pi over 4, which means it has the same characteristics as pi over 4 does in which quadrant? 1. Now, in quadrant 1, what is the sine of pi over 4? So the sine of that is root 2 over 2. Now, is that the x or the y coordinate? It's the y coordinate. Now, in quadrant 4, is the y coordinate positive or negative? So what is the sine of 7 pi over 4? That's how this works. It will be, yes, but I'm just looking for the sine value, right? Okay, I'm just looking for the sine value. See what I did there, guys, is I'm looking at just the sine values. the cosine value is still going to be the same x value because that doesn't change. The x value in quadrants 1 and 4 are both positive, okay? Because you're to the right of 0. Does that make sense how we bounce that around?
Yep.
That's what we're doing here. The whole important idea, guys, is if you know this, everything else is a piece of cake. Bomber, can you attest to that? I know you did all this stuff already with the,
Yeah, no, just a lot.
it's Q1.
Yeah.
As long as you know Q1, everything else bounces. Okay? Quadrant 1. All right, quadrant 1. All right, let's look at another one.
Can you run over that one again?
What's that?
Can you run over that one again?
Okay. You're okay with putting it in the fourth quadrant, right?
Yeah.
You're okay with bringing it up for being the reference angle. Now, remember yesterday when I drew the axis, we drew that right triangle. Oh, let me do this. Give it a second so I can. Remember when I drew this, and then we went around and flipped it all the way around? So as you flip this thing on, flip this around, oops. And I'm down here now. I want to clone it and put it back up top so you can see this. These 2 points share the exact same x-coordinate. These 2 points, because they're both 45, 45, 90 degree triangles, they have the same y value, but this one is negative. So as long as I know that this is the same reference angle as to here, I know that their coordinates are going to be identical, but just with different signs, S-I-G-N. I just have to know what quadrant I'm bounced within to know which one's negative and which one's positive. That's how that works. It looks ungodly complicated for just a translated 45, 45, 90 triangle into a different quadrant. Okay? Does that make a little bit more sense?
Cosine is x and sine is y.
Yes, sir. What comes first in the alphabet?
X does. I thought you were talking about just the whole alphabet.
You know me too well, because that would have been something I would have done.
What? Yeah, I know.
Yeah. All right. Let's look at another one.
A comes
Again. Oh, I forgot to do that. Oh, well. It was what? Negative 4 pi over 3. I'm going to find the cosine of negative 4 pi over 3.
So you want to get.
Correct. When I'm working with cosine, I'm working with my x values. Yes, sir.
But then, like, usually if we were to plug it in a calculator, we get a single numbers answer, coordinate to an answer.
You're not getting the coordinate, you're getting the x value of an ordered pair set.
Also, that x value is the
Right.
answer.
Yep. You're not looking at both, you're not looking at sine and cosine. Just asking for the cosine value. Again, when I start this, I have to figure out what quadrant the original problem lies within. Negative 4 pi over 3 is 1 1/3 pi. Everybody agree with that? So I'm coming over here, which means my reference angle is what? Pi over 3. Everybody okay with that? So my reference angle being pi over 3, that means that the cosine value over here is going to be negative. Now in the first quadrant, pi over 3 had an ordered pair. If you remember, pi over 3 was your 30-degree angle. Your 30-degree angle cosine is adjacent over hypotenuse, root 3 over 2.
Wait, hold on.
Pi over 3 is a 60. It's a 60.
Oh, did I say? I'm sorry, I looked at the wrong value.
Should be pi over 3.
Yeah, because what happens here, this is 1 and pi over 3. I just drew it wrong. Yeah, I'm sorry about that. It should be up a little bit higher. Whatever.
But
So
the
it's-
reference angle still the same?
yeah. I just started writing out the wrong. I was thinking I was at 30 for some reason. I'm sorry. Again, if I'm at 60 degrees in the 30, 60, 90 for pi over 3. My cosine is my adjacent over hypotenuse. My adjacent now is 1/2, or 1 over 2. So it's 1 over 2 for adjacent hypotenuse for the cosine. And then it's in the second quadrant, which means it's negative 1/2. The cosine value of that becomes negative 1/2. Again, the whole idea here is being able to mirror it out of the reference angles in quadrant 1 to find the different values. Let's look at one in degrees.
Okay.
Cosecant of negative 225. It's okay. Draw your reference angles. Negative 225. What quadrant will that lie within? 3, 2. We're coming around. This is negative. There's 180, and that's 45 degrees more, I believe. So what's the reference angle? 45 degrees. What's nice about when you're doing these problems that require no calculator, a lot of times if it ends in a 5, what do you think your reference angle is going to be? It's just a matter of figuring out what quadrant you're going to be in. It's usually all I got to worry about. Okay. Now, this is mirroring the same properties of a 45-degree angle. If I'm in quadrant 1, what is the inverse function of cosecant? Sine. So what I'm going to do here is look at my quadrant 1 stuff for sine. My sine value was √2 over 2. Which means the sine value in quadrant 2, is it stay positive or negative? It stays positive, so it's going to be something √2 over 2. But since it's a cosecant, I have to flip it. So it's √2. All I did was flip it and rationalize. I always look at my cosine and sine values. If I'm working with an inverse trig function, I write it out like I would with its parents, if you will. And then from that moment, then I re-rationalize it to get my result.
So that was a sign you would.
Oh, you flipped it.
Uh-huh.
Oh.
Because I know that the sine value, the sine of 45, was √2 over 2.
Wouldn't it be negative though?
Sine is positive in the second quadrant. The y value, okay? So remember, this is positive in the second quadrant.
Still write the coordinates after.
What's that?
You still write the coordinates after.
What do you mean, coordinate?
Like when you write negative √2 over 2 is wrong.
No, what I'm looking at, if I'm just looking for one of them, I'm just filling in which one am I looking at. If you want to, that's fine. It's not a big deal. It's not a big deal. Then your answer would be √2. Okay, so your answer would be √2. Another degree measure. If I'm looking at the cosine of 240 degrees, what quadrant do we lie in?
Third.
We are in the third quadrant. And Jason, my reference angle is 60 degrees.
Who am I? Look at these hands.
So my reference angle is 60 degrees. Now in quadrant 1, 60 degrees has the cosine value of what? It's 1/2. So in quadrant 3, is cosine positive or negative? So your answer is? There you go. Again, notice, all we're doing is just bouncing everything out of the first quadrant. Yeah.
What if that reference number doesn't match up with those measurements?
You don't know how to do that yet.
So we don't do
Then you might have done something wrong. Everything that you're going to get so far will match. We will eventually find pi over 12. Pi over 8. What's that? Without. It is, but it's not half of the sine of pi over 6. There's a big formula to that. It's really not that complex. It's still built off the same thing, but you have to do parts of each of the different angles. So, but we'll get there. Yes, sir.
Why do you use 60 instead of 30?
The reference angle here is when you're down 240 degrees. In order to figure out what the reference angle is, since it's quadrant 3, you take your theta, subtract minus 180. So 240 minus 180 is 60.
All right.
Okay. Let's do a tangent. Let's look at one about tangent. We'll use the same degree measure because that way we already know what our reference angle is. I'm going to go with tangent of 240. What quadrant did 240 get us to? Third quadrant. My reference angle is 60 degrees. And now remember, tangent is y over x. And when you're in the third quadrant, both your y value and your x value are both negative. So what was the sine value of 60? It was 1/2, right? So it would be negative 1/2.
60 was root 3 over 2.
Sorry, I was thinking cosine. So you have root 3 over 2 divided by negative 1/2. When you're working with tangents, it's y over x. Now, crazy vertical fraction over fraction is kind of nasty looking. Rewrite it. This is the same thing. Does everybody agree it's going to become positive? Since it's the third quadrant, I'm not going to worry about my SIGN, my sign for that one, because I know it's going to be positive down there. I'm going to rewrite this as root 3 over 2 divided by 1/2, which is the same thing as saying root 3 over 2 times 2 over 1. What's the tangent? Root 3. So the tangent of 240 degrees is the square root of 3, because that drops out. Woo!
Good job, Jason. I'm proud.
Since you know, like what the side legs are, couldn't you just like say it's root 3 rather than having to like go through it and solve it?
And what he's getting at here, guys, is he knows when you're looking at 60-degree angle, tangent's opposite over adjacent. Isn't it just root 3 over 1?
Oh, okay, so we can just do that.
Yeah, if you knew it off the top of your head.
Okay, good.
What I'm showing you is how you can bounce it out of the reference angle. A lot of this stuff we're bouncing out of the reference angle. But yeah, if you understand how this works out, everything is based off your special right triangles. Everything is based off of special right triangles. Nothing is different. Okay? Secant 11 pi over 6. Ah.
It's going to be exciting.
Oh boy, isn't it just something fun to look forward to?
Yeah, right. Are you going to go?
No. Secant. Hey guys, Secant is it? What's the inverse for secant? Cosine. Again, when we're working with 11 pi over 6, first thing we're going to do is place it. It is almost 2 pi, isn't it?
Yeah.
Your reference angle is pi over 6. I'm dealing with secant, so I'm looking at what? The x or the y value? I'm looking at the x value. Now, at pi over 6, the x coordinate for 30 degrees is root 3 over 2. In the fourth quadrant, does that sine value, SIGN, change? No. No. What's your answer? Root 3 over 2.
And then it's just, wait, it's the secant.
Now,
So then
the secant,
2 root 3 over 2.
very good. The secant value then, since we have to inverse this, we inverse it, we're going to get 2 over root 3, which is 2 root 3 over 3. Take care of everything that you would normally for cosine in this instance. And at the very end, flip your fraction and re-rationalize. Okay? Running short here.
We allowed to use calculator.
I don't want you to. I don't want you to use any calculators here. Yes, sir.
Does that look like that? Or any calculator?
Yeah. You should be able to generate it. Yeah, I want you to, if you can generate it, then you'll be fine. Okay? What? Yeah, you won't remember the triangle. You'll try to memorize it, and it just, things get all mixed up and stuff. What I would suggest is if you know how to build it off of here, you're going to be all right. Now, I know this is going to seem kind of daunting. What I want you to do tonight is I want you to do these by hand.
Now, do we have to show all our work? If we can do most of it in our head?
It's okay. It's okay. I want you to, it's the next page.
All those,
Yeah. I want you to do those without a calculator.
all those tonight?
Yes, sir. What page was it? I think it's 79. Yeah, 789. All right. So as you go through on that, remember, everything you do is built off of the first quadrant. My big giant suggestion to you is as you start this up, is to draw a picture of your first quadrant somewhere. Label it out. Know what your 30, 45, and your 60. Pi over 6, pi over 4, and pi over 3. Label those ordered pairs. Everything is based off of those ordered pairs, just mirroring themselves into the 4 quadrants. Everything just mirrors itself out. Okay?
How much time do we have left for the end of class?
3 minutes.
Oh, we can do it.
All right. You can at least start drawing your reference angles.